Hi, I'm Nagesh Susarla from the YQL team, and today I'll be talking to you about building open data tables with YQL Execute. So before I dive into the depths of YQL Execute, just wanted to start by saying what exactly is an application. Now, an application is typically composed of the applications such as the stock ticker application on the iPhone or the mail application on the Mac, or for that matter the weather application on the iPhone exactly, or the housing maps, which is a mashup application. They are composed of, they have common themes. They have data manipulation and fetching, obviously, fetching and manipulation, and data visualization. Now today's talk is mostly focused around data fetching and manipulation and how you can do it with YQL. But to start with, where do you get all this data from? When you're talking about web services, you get all this valuable data from the various web services, like you can have just raw feeds, XML, RSS, or Flickr photos information, or delicious bookmarks information, or the various web services that are outside of Yahoo, obviously, that you get the valuable information. Now, let's take the scenario of you building an application with all these web services. So this is supposed to be you. So you're working on your machine and trying to build a mashup with the various web services. Now I have maps, Flickr, search, and weather for that matter. Now the point is to get all this data into your application by writing some glue code. And now, so you write a bit of glue code for maps, you write a bit of glue code for Flickr, and you write a different bit of glue code for search, image search in this case. And same for weather. Now again, here you have to enter the correct city name, you have to format the URLs correctly, you have to use the API documentation, etc. to get all this information. Now, before you wrote the glue code, you did the work of going to the various documentation URLs, reading about each of these query parameters, path parameters, headers, etc., and wrote the glue code yourself. So that was the work you had to do, and each one of us had to do. So that's where YQL steps in and removes this redundancy. So when YQL steps into this picture, YQL binds to the various tables. So once you build a binding for a particular table, maybe it's done by one of us, others can make use of it without having to worry or without having to read the documentation over and over again. Now, you as a developer have to issue a YQL statement which contains select, describe, show. And I'm sure by now you are familiar with the familiar SQL-like syntax which YQL exposes, which is very easy to understand, and by describing a particular table, you know exactly what the bindings, required parameters, optional parameters are for a particular table. Now here we are focused more about the bindings. So what exactly are these bindings? Now the bindings tell YQL how to talk to a particular endpoint, and they specify or they make it declarative so that YQL can understand how to format the URL, how to add the various parameters, fetch the request, and then parse it and return the data back to the user. So rather than just talking about it, I'll start with an example. Now this is exactly what we had to do to integrate search into YQL Open Data Tables. So that's the Open Data Table we used. It's a small XML file which has some key components here. And the key components being this URL with holes in it. So we actually call it the URI template. And YQL implements a URI template specification. That's the reason you can actually format the URL in such a way which has particular holes in it which are filled later on at runtime by the various input parameters that you gave. Now in this particular case, we had the query attribute as required. So that's the only required path parameter that is sent to this particular query. The remaining are all optional, and they are param type of query. So they are query parameters. They'll be appended to the end of this URL before the URL is actually created and sent to the web service. So that's Open Data Tables 101. Now, once you've created your Open Data Table, what do you do with it? Now, the way to import it into YQL is to use the use verb, or better put actually, employ the use verb to import your table definition into YQL. So you take your Open Data Table, make it available at a publicly accessible location, and then from YQL you can say use the URL to definition as the table name. This is the namespace you're giving the particular table name. And then you would say select star from the namespace where the required keys, optional keys, or binary and or etc. all the other binary operators that you want to provide. So that's how you import a table. And now just by doing this, this table becomes a first-class citizen in YQL, similar to all the other tables that we have in our collection. So just by doing this, this data can be mashed up with any data, be it a built-in table that Yahoo provides with YQL, or be it a table which exists on our community stuff. So all this data is included together. And the problems are as follows, right? You have pre-processing or post-processing and the mashing up problems. These are the main three categories of problems. The first category being authorization and authentication. Now this falls into pre-processing, where let's say you have OAuth or Amazon Auth or Flickr Auth or many other auth protocols which require you to send some kind of credentials, signing, etc. before you actually send the request to this particular resource. So that was one case. The second case was obviously joining data across multiple services. Now this is the mashup case where you want to, let's say, go to multiple sources, aggregate this information, and then enhance your result based on some criteria. Now the third one was enhancing data, which is similar to the joining data, but let's take an example of augmenting a web service, let's say, which provides city and state information, and you want to add or annotate it with geo information. Let's say when Twitter didn't have the geo information on and you knew the city and state where it was done, you could annotate it with the geo information if you wanted to, and then return this data. That's another example. Now the next one, which is creating APIs from web pages. This is one of my favorites. I call this the Scrapi, and it's a very popular way of adding APIs to websites which don't have APIs. So websites typically, for whatever reasons, didn't have time, money, material, resources to build an API. But we are API junkies. We need APIs. So what do? You create an API with this by just scraping it, and then hope that one day they'll create an API for themselves and retrofit this to actually match the APIs that they provide. Now the next step was data transformation, transforming from XML to JSON, JSON to XML, or be it transforming XML into something like Google Earth's KML format. How do you do that? That was another category of problems. And then finally, we wanted the ability of users being able to run logic in the cloud, being able to run business logic in the cloud. So these were the main reasons where we thought of YQL Execute. So naturally, there were two choices that we had. So the first one was to enhance the YQL language. We started off by saying that YQL should be simple, it should be familiar to developers, it should look like SQL because it's familiar to developers. But then we were in this fix. We were in this fix of, okay, now we have to augment this language and make it probably have a bit of a learning curve. That was one of the choices. The second one obviously was to pick a language which is familiar and loved by developers. Obviously, it has a lot of cons because it doesn't change YQL's familiar syntax. Now, the pros of the first approach, as I can see, is it would make us look geeky, and maybe my mom would be proud that I created a new language. But other than that, she wouldn't be proud that nobody uses it. So I didn't want that to happen. So finally, we picked a language which is familiar to developers and loved by developers, and that was JavaScript. Obviously, JavaScript on the server side. Now this 2.5 years ago, so that's before everyone picked up on JavaScript on the server side, we started thinking about adding this. So what exactly does it take to use this JavaScript execution environment on the server side? So in your open data tables, we added a new element called execute. Rather than bunching it and pairing your query with this JavaScript, which again makes it complicated, we paired it out, separated the JavaScript part from the actual YQL query, left the YQL query alone. And now you add the execute element in which your JavaScript resides. Once it has JavaScript, the entire request lifecycle is given to the JavaScript. The execute element gets total control of the request lifecycle. It can decide whether to process the request based on parameters. It can validate the parameters and say, no, I don't want to process this request, so I can return an error if I want to. Or it can make multiple web service calls. It can make multiple nested YQL calls, as I'll show in the later slides. And then obviously we had to provide a JS API on the server side for the common tasks to be possible. Now I'll talk more about that. Now in addition, we also added E for X, which is ECMAScript for XML support for manipulating the XML data structures. So that's just XML literals in your JavaScript, simply for doing XPath and the XPath filtering, etc. Now we also heard some wise people say things like this. So we decided we'll stay away from DOM and just keep it simple with server-side JavaScript. Okay, so the JS API. Now moving on to the JS API, what does YQL execute provide you? Now the execute needs to have implicit objects. So we start with the request object, which lets you make requests outside. So it has the various parameters to add headers, path parameters, query parameters, matrix parameters, and it also has facility for you to make put requests, post requests, get requests, and delete requests. I mean, just the HTTP verbs that are allowed. So that is supported on the request implicit object. Now we also support chaining of methods. So chaining of method means it makes it very simple. You can just say request.accept dot header authorization is this dot query. So you continuously chain this request and then finally call a get, which is actually maps to your HTTP method, which is get, and then get the response and then decide what you want to do with it, parse it, manipulate it, or whatever. Now in addition, we also have the response object. Obviously you need to have a request and a response object. So the response object lets you set the data that you want to send back to the user. So you set that by saying response.object is data. And this data can either be XML or JSON, depending on what you want it to be. Now the engine converts it into the correct format that is requested by the user. That's one of the benefits again of YQL. In addition, if you know this data is going to be stale, if this data is not going to change, then you can set a max age right inside execute. If you know this data is about zip codes, which is not going to change very often, you can set a high value, which is set in seconds, and it goes back and sticks into our cache. So the next time a request for the same request lands on our servers, it's picked up from cache, and it bypasses our rate limits. That's just FYI. So our rate limits are applied after the cache. So you get the benefit of our caching. Now we also have the Y object inside of YQL execute, which has the various utility methods. Now the utility methods are including external JS files. Now why did we add this? We literally wanted to reuse the JavaScript that's out there on the web. Now to let us do that, we wanted y.include so that you can just include JS, which is already out there, and call functions in your execute directly after that. Now making nested YQL calls. This is very important because you rely on other people's work. They've already built these open data tables. If we didn't allow this, you would have to re-implement the tables yourself again in your execute. So rather than doing that, you say y.query and include this other table which someone else has built and get the data from it, then enhance it exactly. Now importing external environment files. Now environment files let you declare the tables. So by doing this, you are actually importing the namespaces which you can again use inside your execute to call more of the tables. Now conversion between the various formats is also utility methods which we provide. And obviously last but not the least is making external REST calls. This is the basic primary purpose for execute, so that you can make multiple REST calls and do them asynchronously. So asynchronously and in parallel. So you can make use of YQL engines parallelism and get data in shorter amounts of time. So I'll go over the various features with examples because I'm sure you must be like, okay, that's a lot of information. How do I remember all of that? Okay, no problem. Let's go over it with an example. So hello world, what does it take to write an actual execute file? So the only difference between this open data table and the previous one is the execute element that I've added. Now in the execute element, I have now added response.object as result, and I have a data element with hello and the E for X sign for adding templates. So I add a template called query, which is actually a key which is passed in. So if world is passed in, I am supposed to get hello world as the result. So this is E for X in short for you. It lets you have XML literals right inside your data. Now you can also have JSON right here. It's your choice. Whatever you're familiar with, whatever you like, you can use here and send a JSON response back. So now, as I said before, I would employ the use verb, import this table, and then say select star from hello world where query is world. And that's what it actually gives me. And this is the information that the YQL console shows me. And this is the YQL console, just FYI, where I'm actually testing out my queries and seeing what data is being returned by this query. Okay, now let's look at a little more complicated example or a little more involved example where I want to augment search.web. Now if you look at search.web, which is just a search results page, it contains a list of searches which match the query, and I happen to be hungry all the time, so I have queries pizza there, and I get a list of results. Okay, I know that, you all know that. Now what next? Now we want to augment it. What if you wanted to augment the search results and add images associated with each of these links? So what you actually want to do, just if you think about it, for each of the results that's given to you, you want to make an image search call, find the appropriate image if there is one, add it into your response, and then return this augmented result back. That's what you actually want to do. So how do we start about, how do we go about doing this? So first things first, you write an execute because you have an involved example which does a lot of mashing up. First you do a y.query, select star from search.web, I only want 50 results, so I specify that here. And then when query equals @query is a way to parameterize the YQL call. So @query now takes the value of whatever QS is, which is the query variable from the ID. Okay, what's next? Next is I loop over the result using this for each loop. Now this for each is actually syntactic sugar. It's supported by an E for X extension that we are using here in this case. So we enumerate through each of these search results, and for each of the search results I'm saying select star from search.images. I want only one image where query is the query that was passed in and the URL that maps to this. I give it as a parameter. So for each one, I'm making another image call. Fair enough. What's next? Now once I've done this, I have another for each loop, which loops over the results because I had collected all of them in the images array, because I had pushed it in images.push, and now I get it from each one of those, results.result. If there is an image, then I use e for x and append it again to the actual result. Finally, I return the search result. Now, just to make it less confusing, here is the entire code snippet that we worked on. Now, some of you might be wondering why I have two for loops, two for each loops, when less is better. I mean, you could have done it in one for loop. Did you know that? So, actually, yeah, I could have done it in one for loop, but we are trying to use the parallelism or the async requests that YQL provides. By just calling a query and not asking for the request, you are queuing it for execution immediately. So this is queued up and executed in parallel, and it blocks only the first time when you call results. So it blocks the first time when you call results, and from then on it actually gets the results from each of these queued query objects, and then finally the image is actually appended. So you are so to make use of the parallelism that is offered to you by the YQL engine, you make queries or you make REST calls without asking for the response. So that makes them go in parallel. If you ask for the response and depend on it right away, then we have to block and wait for the response to come back. So that's in short about unified web plus image search. So now after this, what does our result look like? Now if in console, after this our search looks like this. So we had a result object and we created a new image tag and appended the result that we got from the other image, search.image query. So that's search plus search web plus image for you right there. Okay, so going further, now what do we go on to? Now this example shows you the first bullet that I was talking about, which is authorization and authentication. To make it possible to contact or make requests to resources which require OAuth. Now Netflix catalog apparently requires OAuth, two-legged OAuth. So that is done by including two OAuth.js files, I mean OAuth.js and sha1.js, which is already existent on Google code. So we don't have to rewrite all of that. We just include the JS and go through the various steps of the OAuth protocol. I'm not going to go into details of this, but this table is already available on github.com. So I mean on the GitHub repository. So you can go there and look it up. So the next up is insert, update, and delete. So when we first came out with YQL, we just had the select verb, and that's why we used to call it select star from internet. But after we after we came out with insert, update, and delete, a few people asked us if we are going to delete from the internet. I mean, yeah, we're not deleting the internet, we're just deleting a few records from the internet, but it's not like that. We are not deleting anything. It's only the APIs that support deletion, which support the verbs, the HTTP verbs like delete, put, post, are supported by YQL. We don't do any deletion from the internet, to be precise. So we modify data on the internet with the APIs that support, like creating tweets, adding new blog entries, or updating DBs. If your DBs are web accessible, then we can update the DBs, etc. Now the changes for this are very simple. Now it's the same format. To be very familiar and consistent, we have the same open data table bindings. We have the same required and optional keys inside your query parameter, inside your query that you give. And finally, let's look at an example. I'll try this. So what I'm trying here is inserting into bit.ly.shorten, and the values are like http cnn.com. Now let's see if Bitly comes up with a URL that's shorter than CNN.com. Now apparently not. The short URL is longer than the long URL that I passed in, but that's fine. But the point is that I'm able to actually insert into bitly.shorten and I get a short URL. So that shows you an example of shortening. Now the other example that I have here is updating my profile status. So as soon as I do this, it says whether it's okay or not, and then I go to updates and see whether it has updated it. Okay, it has updated it 12 seconds ago. Oh, that was fast. That's pretty good. So far so good. Okay, the demo gods are with me. The other example is inserting into social updates. So let's see if this one works. Again, you insert into social updates. The syntax is exactly like SQL, so no surprise there. Obviously, YQL is very similar to SQL for a reason. So it gives me a status which says it's successful, and I actually want to see the YQL update. Okay, that's good. I'm happy with the demo. Now I go back to the session. And actually, now let's see what was involved in writing this table. So, table looks very simple actually. The only change that I have here is the insert element. So I have the insert element up there instead of the select binding. So it maps to the verb that you're actually doing. So select maps to the select. So a get maps to a select, and insert maps to an insert verb. So fair enough. Now in this case, Bitly accepts insertion, or Bitly shortens URLs just on a simple get request, get HTTP method. So we don't even have to write an execute to make this happen. And the reason for this particular URL is I just wanted to show the power of URI templates. So you can have URI templates, and since we support the URI template specification, you can have arbitrary URI templates which can sort of expand before the requests are actually made. So another example is inserting into Foursquare check-in. Now Foursquare, as you know, lets you check into a location. So, and it supports basic auth. So all you need is the username and password and the venue ID for that thing to happen. I've omitted a few parameters here for brevity, but there are other optional parameters that you can add here. So all I do in my execute is compute the auth header that I want to actually send with the request, then do a post request, get the response, and set it as the response.object. That's all I had to do to actually include or import Foursquare.checkin. This is actually a table which is already there in the community tables. So I just picked it up from there, removed a few parameters and added it as an example. This shows how simple it is to add different kinds of verbs. Now if you wanted to do delete, all you would have to change is the element on top, which would say insert. Instead of insert, I would have delete, and I would call the appropriate HTTP method, which is delete here. So del is the verb we use internally, because delete is a method which is reserved in JavaScript, obviously. Okay. So spoke about YQL insert, update, and delete. Now it's all about structuring your queries. Now when you create, when you use YQL for your entire application, you can imagine that there are various queries for different parts of your application. And structuring your queries becomes very important. Rather than declaring these use tables along with the queries, you want to separate out the declaration of the uses from the actual query. So you can use a standard config or a standard declaration path for each of your queries that you're making. The same declaration path. Now, nfiles provides the way to separate the queries from your table declarations. And it enables you to declare the tables. And in addition to that, you can also use the set keyword. So you can set different parameters on particular tables. I'll take an example of that shortly. But once you have an environment URL, you would simply make a query.yahooapis.com v1 public YQL, that's your endpoint, and add an env parameter with the environment URL. All you have to do is make it publicly accessible and then give your query, rather than having your use statements interspersed with your query, which makes it very long and unwieldy. You can't refactor your query very easily, etc. So what can an environment file look like? Now, environment files can have various things. Now, environment files can start with the declaration of the tables, obviously. You can declare your tables. Now, in addition, you can also import the work of others. You can also import or include environment files which are external by saying env and the external environment file. Now, you want to do that rather than repeating everything that's there in that particular environment inside your environment. Now, in addition, the reason for doing this is so that you can set different keys. Now, the reason for setting these API key and token right inside my environment file is so that I don't have to repeat the static bits of information along with my query. So once I have this API key here, anytime I use Netflix catalog, I can omit the API key. Even though it's a required parameter, I can omit it because I'm using it in my environment. It will be available to all my queries transparently. Now, the other benefit of using environment files is if you want to use YQL storage. Now, before I talk about how you can use environment files in YQL storage, I have to obviously introduce you to YQL storage. Now, what exactly is YQL storage? Now, we at Yahoo are fortunate to have a distributed data store, internally called as Sherpa, which is deployed across the world. So, and it's a distributed hash table, so it has various things like consistency, replication, and all the good ilities, reliability, scalability, and all the ilities, various ilities that go with distributed data store. And it's used by a lot of different properties which are already online. And this is our way of exposing the distributed data store to our users. So YQL wraps on top of this Sherpa and exposes it to users. So what do you get out of it? You can insert, update, delete, or select information which is stored and replicated across multiple colos now. Now, in addition to wrapping these tables, we also actually layer it with some Unix goodness. So we add some privileges on the various keys. So we have read, write, update similar to the Unix privileges. We layer them on top of the keys that are stored in Sherpa or the distributed data store. Now, what does that actually give you? Now, let's say you wanted to insert some data into Sherpa. Now, if you inserted, let's say, a URL, so what will happen here is insert into YQL storage admin, name is foo, and you give a URL, which is your environment file. Now, this gets inserted, and you get three keys as return values. Now, the first one is the execute, second one is the select, and the third one is an update. Now, the execute key is special to YQL, obviously, because only YQL engines, none of us, only our engine boxes, can actually read through this data and see what's inside your store entry. Now, to read the data, so the reason for having an execute key is so that you can share this particular key with your users or with your application. You can share it or show it anywhere you want because the data is not accessible to the user. Now, the select key is what is required for you to actually see this data. So you keep this secure from the user. And the update key is what is required to actually update this information. Now, with the update key, you cannot see the data, you can only modify it. So that's the principle that we use to have this various keys, so that you can distribute the execute key to your users without worrying about your data getting leaked. That was the primary purpose of YQL storage. So now with that, so that completes the entire story of using YQL execute along with YQL storage possibly and augmenting and enhancing services. And in conclusion, YQL lets you build applications that run faster. Now, the main reason for this is because the service in the cloud is doing all the work for you. So let's take an example of a cell phone, right? You have if you're like me and you have a service provider or a carrier like mine, the network is like a straw coming down from the carrier. So if you imagine building an app on the cell phone, you cannot go to multiple web services, get the data, mash it up, pick the pieces of information that you actually need, and then show it on the cell phone. That's going to take a long time because of the network, carriers, etc. So rather than doing that, imagine sending a single request to YQL, which does this work in parallel, which is globally deployed, which does it work in parallel, gets the data, mixes and matches the results, and only sends this tiny bit of information that your app actually needs down the small pipe, whatever it is, to the application. So that's the scenario we wanted to support, and that's what YQL is today. So you get smaller amounts, which obviously is less parsing cost on the client. So you have all this valuable data, and you have a query language, YQL, to actually deal with them.